These are more difficult. And my point of why this is exciting is, again, my daughter came home one day. She's like, Daddy, I want to see graphs of stuff. So I showed her a line. And after a while, she saw the line. She's like, okay, that's kind of boring. Can I see something exciting? I was like, yes. Thank you for asking. So we looked at some of these other graphs. And she said, Daddy, what's your favorite function of all time? I said, the barcode function. Do you want to see it? Yes, I want to see it. And so we looked at it. She's like, it looks like a barcode. So it's called a barcode function. So anyway, it's nice that we can look at graphs that are different than what we've always looked at in the past, which is lines and quadratics or parabolas. That's basically it. There's more to life than that. Can you imagine if all you got to eat in life was like French fries and broccoli? You'd be like, okay, I like one of those choices, not the other, and I'll live with it. But today we added pizza and steak and tacos and all the other good things in life. So grilled cheese, yeah. Oh my, mac and cheese. All right. So y equals 1 over x is the parent function for this graph. The question is, what is 1 over x plus 2? Is that going to be a horizontal shift or a vertical shift? You remember anything for Friday, what I want you to remember is this. If it's on the inside, it's horizontal. If it's on the outside, it's vertical. Is this on the inside or outside? Inside. If it was on the outside, it would look like that. So this is on the inside. What would you plug in to make 0? -2. So it's a horizontal shift to the left 2. If you also remember from our graph on Friday, this had a horizontal asymptote at 0. And since there's no vertical shift, that horizontal asymptote stays at 0. And this is the shape that it made. That's it. Can anybody tell me why I have a horizontal asymptote of 0? What does that mean? It means that the output can't be 0. So that means that no matter what you plug in for x, you can't get an output of 0. And if you don't believe me, go ahead, try. Try to plug anything in for x and see if you could get a 0 for an output. And I promise it won't happen. You won't be able to make it happen. We can just do it algebraically. 0 equals 1 over x plus 2 and see what you would get. Cross multiply. You get 1 is equal to 0. No solution. You can't. Impossible. Okay, state the domain and range. Domain. What x values, how about this? What x values can't you have? -2. So from -infinity to -2, union with -2 to infinity. How about the range? Piece of cake, upside down. All right, next one. What's the parent function? Y equals x to the 1/3 power, yep, or the cubed root of x, okay? So something like that. What does that graph look like? Yep, kind of like the snaky thing, right? Something like that. Great. So, -3, is that on the inside or outside? Inside, so is that horizontal or vertical? Horizontal, so it moves it to the right. How many units? 3. Again, you can always take these and you can plug them in if you, if you're wondering if they're correct. X minus 3, parentheses, to the 1 divided by 3. That's how I type it in. Whoop. 1 divided by 3. Press graph. There you go. All right. Looks like a complicated graph. We sketched it just like that. Domain. All real numbers. Range. All real numbers. Good. Uh-oh, what's different about the next one? What's the parent function? 1 over x squared. How is 1 over x squared different than 1 over x? They're both up in the positive portion because a squared will make something positive. So we got a couple things going on here. First of all, x minus 3 is on the inside or outside? Inside, so move it horizontally to the right 3 units. But how about this negative up here? Is that negative on the outside or inside? It's on the outside, so will that be a horizontal flip or a vertical flip? Vertical flip. The 2 simply is a stretch by a factor of 2, and we're not going to worry about taking care of those type of things today. Don't worry about that constant on top. Really what we have to focus on right now is the parent function. I'll draw that in blue. Looked like this. What we want to do now is we want to move everything to the right 3 units. So that's our vertical asymptote of x equals 3. And then our horizontal asymptote stays at y equals 0. And as you said, this is going to move over 3, and then it's going to be reflected over the x-axis. So that's my graph. The green one is my graph. What is the domain of that green graph? A infinity 3, 3 to infinity. Range. Where do I start? Negative infinity up to, do I include 0? No way, Jose. Okay, next one. Parent function, y equals root of x. What does that look like? That thing? Okay. Is the 4 on the inside or outside? What would you plug in to make 0? 4. So therefore, we move 4 units to the right. The plus 1, inside or outside? Outside. So you move 1 unit up. So that's where its start is going to move. But there's a negative in front of the x. Is that negative on the inside or is it on the outside? So if there's a negative in front of the x on the inside, is that a horizontal flip or a vertical flip? It's a horizontal flip. So therefore, instead of headed off to the left, it's going to head off, or I'm sorry, instead of headed off to the right, it's going to head off to the left. It is somewhat odd, strange, different, but like I said, we want to graph stuff that's exciting. And this is cool. So I type it in, we got plus 1, and so we took about 50 seconds and we graphed that, and I think that's a pretty accurate graph. What do you guys think? I mean, you should be impressed at how quickly you could generate graphs without having, or would you like to just sit down and make XY tables the whole time? That takes forever, doesn't it? And how accurate is the graph going to be? We did this lickety split. Boom. Next one. I'm going to rewrite this one so I can understand it better. I'm going to write y is equal to a negative, parentheses, x minus 2 to the 5th, and then plus 4. Parent function. X of 5th looks something like that as a parent function. The minus 2 is on the inside or outside. So it's going to move horizontally to the right. How many units? 2. Plus 4, inside or outside? So it's going to move up 4 units. When you take this thing and multiply it out to the 5th power and do all that, are you going to end up with a negative x to the 5th or a positive x to the 5th? A negative x to the 5th, right? Because it's negative out front. So will it start down and finish up, or will it start up and finish down? Start up and finish down. Oh, forgot to do domain and range. Sorry, my allergies are getting the best of me here. For the red one, what's the domain for that one? Negative infinity to what? 4, bracket, and then range from 1 to infinity. Next one, domain. All reals. Range, all reals. Good. How the flute solo will go today? Good. All right. She had her flute this morning. Have you seen Anchorman? That flute solo, that's epic, isn't it? That is awesome. So yeah, I was wondering if you're gonna kind of that would be a great Tiger's Roar thing to do, to reenact the flute solo from Anchorman. Would you agree? I would go nuts. I would scream. All right, y equals 1 over x. That's my parent function. So what's the transformation here? Is it going to be vertical or horizontal? Vertical. Why? Because the plus 3 is on the outside, so I'm going to move up 3. So instead of a horizontal asymptote of 0, I have a horizontal asymptote of 3. And my vertical asymptote stays here, right at x equals 0. Domain. What we got? Negative infinity to what? 0 union with 0 to infinity. How about my range? Negative infinity to 3 union with 3 to infinity. So again, we exclude the value 0 from the domain. Obviously, you can see you can't plug in 0. And then from the range, 3 is excluded. You can never get 3 out for that function. Okay, we're gonna do 3 more, and then we're gonna let you work. Uh-oh, now we have a 5th power one. Ooh, we haven't even talked about that yet, have we? Well, but it's in the denominator. It's a rational function with a 5th power. So if you look at this is first power, and they are in opposite corners, aren't they? But what happens when we do squared? We end up with this same side quadrants, right? So what happens is when you square it, it's going to be positive. That's what happens to the parent function. The negative makes them flip over. But because if you plug in a negative, you get negative outputs. If you plug in a positive, you get positive outputs. That kind of gives it its shape. So if it's odd, opposite quadrants. If it's an even, same quadrants. So here you have to the 5th power. So we know it's going to be opposite quadrants. So I will sketch the parent function y equals 1 over x to the 5th. The parent function just looks like this. Looks just like the 1 over x. It's like, well, how can it look the same? It doesn't. It's a little bit more stretched, but that's okay. We'll just draw it the best that we can. So what kind of shifts happen here? Which direction? Right? 3. Is there a vertical shift? No. What else happens other than right 3? Yeah, it switches because of the negative, so it's a vertical flip. So instead of being in the bottom one, it's going to be in the top one. Instead of the top one, this one's going to be in the bottom one. So what's the domain? Infinity to 3, union with 3 to infinity. And what's the range? Infinity to 0, and then 0 to infinity. Fourth root of x. Is that going to look like a cubed root of x or a squared root of x? Squared root of x. And so the parent function looks something very similar to that. Okay, I don't have a negative on the inside. I don't have a negative on the outside. But what value would you plug in to make 0? -3. So it shifts it to the left 3 units. What's the domain? -3 to infinity. What's the range? 0 to infinity. You guys are so smart. What do you plug into x to get 0? So I solve 2x plus 6 is equal to 0. Okay, we're going to skip that one. We're going to go to one of my favorites. If you flip it over. Negative cube root of x squared plus 4, which is, parent function of y equals x to the 2/3. That's how I write it in rational form. Remember what that looked like? It's a bird. So what are my transformations? Up 4 and a vertical flip. It's an upside down bird. It's flying upside down. I don't know what birds actually do. I know planes fly upside down, but I've never seen a bird fly upside down. They do circles, loop-de-loops. What's the domain? Domain is all reals. What's the range? Negative infinity, positive 4, bracket or parenthesis?